Hi everyone. In this paper we try to introduce a bit of data validation in answer set programming. So let me give you a bit of context why we did this work. And essentially answer set programming is a declarative programming language, and it features many constructs to ease knowledge representation and reasoning. Among them the notion of object variables, very convenient to have a compact representation for specifying combinatorial search and optimization problems. And somehow so far the research concentrated a lot on optimizing the computation, and maybe there was not a lot of space for data validation, and usually the arguments I hear are that often the input comes from some other module and then it's produced automatically, maybe validation has been done there, so we can rely on those data. And maybe the other argument is that we don't want to introduce any overhead on the computation of stable model or answer set. Anyhow, let me try to convince you that we should change something. So programmers do mistakes, so let's start to accept this fact. Indeed, it's not a surprise if you ever coded, you did some mistakes and then you fix it. Maybe depending on the kind of mistakes that you have done, you lost more time than it was accepted. So it's normal, guys, we are human, okay, so we do mistakes. The problem is that sometimes we are even diabolic because we stay with our mistakes and we continue to do that. In particular, being part of the ASP developers, I'm wondering what we are doing to prevent such mistakes. And let me say that in my opinion we are not doing too much. Maybe we are doing just this, so letting the programmer add comments to their complicated and long encoding. And let me try to show an example, and it's the night tour. We know this problem. I invite you to check this encoding online, and then you can see that the encoding is filled in with comments, and some of these comments are even trivial and just explain what is obvious, like this one, okay, that there is no tour for an n times n chessboard where n is lesser than 6. Good, I can understand this very well from the constraint. So I don't really need this kind of comment, but maybe I need other kind of comment, like the fact that sides given move are input predicates, the fact that move is an output predicate, and so on. But let me say that I was a bit surprised to see this kind of lines in this encoding. In particular, the first line of code specifies a size of 8, but then there are constraints that check some property on the sides, because actually, yes, the sides should be an input predicate, not being part of the encoding. So making mistakes with declarative programming is not so impossible, it's actually quite common, and I will say it's even frequent. Now we can try to understand how it's possible that that line was entering the encoding. Obviously, since we don't have a time machine, we can only speculate a bit and try to reconstruct a possible scenario. So maybe the developer started to type in an encoding with their favorite text editor, and then at some point, since the guy knows that long complicated code must come with comments, it started to introduce comments here and there. And then maybe since the guy is also aware that you should never release a software without properly testing it, at some point the guy started to introduce tests. And he did in the laziest way, maybe by putting the test case directly inside the encoding. And then maybe I can imagine the face of the guy that was saying, I'm sure I will delete later when the test will succeed. Okay, it's now 10 years that it's there. This is a source of bug, obviously, so we want to prevent this. There is more we can say about the encoding I've shown you, and it's maybe that concerning the input and output documentation at the header of the file. These are just for human, but let's say that it don't really say enough, it doesn't say a lot. For example, for the sides predicate, we only expect a single instance of this predicate, and then must also be positive, but this is not stated in the documentation, and also the documentation is just for humans, so it's not stated in a machine understandable way. And and maybe we want also to enforce n greater or equal than 6 and even as a requirement, and maybe you want also to specify an upper bound for n, okay, because I think no one really expects that you will execute the encoding for n equal 1000, okay, or if 1000 is okay, what about 1 million, okay, and so on, okay. So usually an upper bound you can enforce always. It's not a bad idea. About give and move, it's very ugly to have these 4 arguments there, not linked together, but technically we know that the first 2 represent a cell of the grid and the second 2 represent another cell of the grid, and maybe we can even, we also know that they are, the 2 pairs here are linked together because they must represent a correct move of the knight. This is not stated and obviously is also not checked. Let me argument in favor of fail-fast approach. Now this is not just my opinion, the idea is quite popular in computer systems, and if you check from Wikipedia you will see that fail-fast systems are usually designed to stop normal operation rather than attempt to continue a possibly flowed process. Why? Because if you start with garbage in the input, the only thing you can produce in the output is garbage, okay, which means everything in the middle, all the process you did was just a waste. A waste of what? Computation power, maybe money. This depends on where you are running this computation. If you are running in the cloud, maybe it can even be non-transferable amount of money. So we want to try to fix this problem. Now there are many possibilities. So one possibility is you did in this way, so up to this point, and now you have to change completely. So which means you have to deal with a completely new language. And I think at some point we have to do this step. Okay, we have to rethink the language with security from the ground up. The problem is if we start this process now, I'm convinced that it will be very hard to convince people that they need to change. So we tried a different approach in this paper, and we tried to somehow let people introduce validation in their encoding, but not changing the way they write ASP encoding, but somehow by providing a tool aside. The idea is you can still produce your encoding in the way you are doing already, and if you want, you can use this validation language aside, or you can even delegate this validation process to one of your collaborators. Let me give you a few examples of this. So let's continue with this night tour problem, and we can see that the sides maybe we can define as a predicate with a single argument. Let's give a name to this. Let's say the name is value. We can specify that it's of type integer with a minimum value of 6, a maximum value of 100, and then maybe we can even specify that we need exactly 1 occurrences of it. Now, if we validate a few inputs or a few, let's say, test case. For example, if we have that the size is 5, we will get this validation failed message that the size must be greater or equal than 6. And for example, if we try to validate something very strange, like the size contains something that is not an integer, then we get some error like this, that we expect a number. And more failing case, maybe if you have 2 occurrences of sides, this may happen if you have this line in the encoding and then you specify a real test case in a different file, maybe then in this case the count is not, it's exceeding the upper bound of 1, and then we report an error, and then obviously if you provide something that passes all the validations, you get an answer set in this case. So maybe you can even do more, okay, so maybe now we are having a lot of atoms in the model and we want to have a more compact output just to check what we are doing. If you want, you can modify the original encoding, but if you don't want to modify it, you can add additional ASP code directly in the file, in the YAML file that we parse with valasp. So in this case, I'm just asking to show only the move for predicate, which means the output predicate. Everything else remains the same. This will be the result. We have a more compact representation of the answer set, but obviously here you can specify whatever ASP code you like. And yeah, we have also other construct in the VALASP specification language here. And for example, for the count, since min and max are the same, have the same value, you can even compactly say just the number. It's just syntactic sugar, but I think it's common case, so better to have it. Now, one question that you may wonder about is how many cases can we cover with VALASP, because obviously we cannot really anticipate all the use cases. So what we did is to leave freedom somehow. Okay, we left freedom to use any Python code in a few points of the YAML validation file. So in particular, in the VALASP entry, you can specify, as we did before, the ASP entry, the ASP key, or also the Python key. In this case, the code will not be ASP code, but will be Python code. And for example, you can use this for global declaration. Okay, if you want to declare a global variable, and I'm going to give you an example in a few minutes. You can also have Python code in symbol declarations, and now there are 3 points where you can inject Python code. So you can inject in the after init, in the before grounding, and in the after grounding keys. Now the after init, the idea is that it's called after the construction of an object, and then in this case you can access the fields of the predicate via self dot the name of the field. And if you want to access the class object, you can do using Python code like self dot and the dunder class field. In the before grounding, this is called once before starting the grounding process, and then in this case you have access to the class object via the CLS variable. After grounding is similar, it's called only once when the grounding terminates, and then again you can access the class object if you want. Okay, let me give you an example. So here what we are doing is in the sides predicate, we want to check that the value provided is even. How can we do this? In the after init, we specify a Python code for this, and if the check doesn't pass, then we raise an exception, okay, and say and report the error to the user. It's a fail fast approach. Now if we run this on an incorrect input like sides 9, we get this error. If you don't go with this check, but you use the previous validation or no validation at all, this will be the result. Okay, so now Klingo here it's going to trying to prove that the instance is unsatisfiable, and then it's going to take a lot of time, yeah, because we removed those constraints that we think should not be part of the encoding. Okay, so now the problem is if you are going to develop and you have to wait minutes or even hours to get an answer, you will lose a lot of time. Good. Next question you may wonder about is, what if I have a non-atomic check? For example, I need to compare two fields, or I have a property that depends on different atoms in my input, or even in my produced facts. So the approach you can follow can be this. So you initialize some data structure in the VALASP Python section, so you declare a global variable essentially, and then in the after init you collect the data you need to process later, and when you are going to process this data in the after grounding method. Let's see an example. So here I'm collecting the sides. Initially I have no value, and I'm going to collect in a post checklist some data. What I want to collect, well, when I'm going to parse the sides, when I'm going to produce the sides atom, I'm going to set the global variable properly, and then when I specify the given move, I want to specify that the arguments start from 1 and they don't exceed this value. Okay, but the problem is I cannot really control the order in which this predicate and this predicate are parsed, so this depends on the grounder, and then we cannot really tune this, or not in a clean way. And then the idea is you collect the value, and after that here you see whenever I parse the given move I collect the arguments, and finally in the after grounding I'm going to check that. Okay, if I get something that is not expected, I'm going to report an error to the user. And the idea is fail fast, you have an error close to the bug and you can easily fix the bug. Here it's an example of execution. You see that we have a size of 8, but then we have a given move that exceeds the size of the chessboard, and this is reported here. Okay, so you can easily search on your input, find the mistake and fix it. And yeah, obviously we use a global variable. That's not very a clean approach. So usually, if possible, we should avoid, because we don't want to declare a global name and then to remember that we cannot use that name in other parts, even if this is quite common in ASP, to be honest. So better if we can store data close to their sources. And how can we do this? Yeah, we can use the class object. So for example, in the after init of the sides, we can access the class object and store the value in a class field, and that's it. Okay, we don't need anymore to declare sides as a global variable. And then when we want to access that value, it's easy. Just the name of the class. We keep essentially the name of the predicate, but we capitalize the name just to be more compatible with Python specification. We can even change this in a future release, but that's another point. Okay, so obviously we can do the same also for the given move. Instead of collecting what we want to post check as a global variable, in the before grounding we can declare the list, then we can populate the list as before in the after init and check finally in the after grounding that everything is going as expected. Well, there are many other use cases that we can cover. For example, for the knight, we know that not all moves are valid. So if we start from this, we expect to move 2 times in one direction and then 1 in the other, and not in any different way. So for example, you see, if I introduce a very strange move here that it's not valid, and I run the encoding as it is, somehow Klingo here is going to have an hard time, because it's losing time essentially to prove that the instance is unsatisfiable, and actually because of an invalid input. So we don't want to lose this time. We want to check for this condition. And then if you want to check for this condition, you can do in this way. So here you see we have the code as before, and we added these new 2 lines. If the absolute difference between the x coordinate plus the absolute value of the y coordinate is different from 3, or the absolute difference of x is not 1 or 2, in this case it's an invalid move. Yeah, no need for strange stuff, just use Python code as you want. You can check this easily. If it's wrong, stop it, fail fast. Everything else is as before, and now you see that we can immediately terminate the computation because we detect the invalid data from the input. Other observation, here we are using somehow the same lines again and again, and that's copy and paste programming is not usually a very good idea. So maybe it's better if we can try to don't repeat ourselves. Let's see if we can. One way can be that we declare in the ASP section additional symbols that we are going to use only for validation purposes. So in this case we are collecting the given move arguments in this auxiliary in range predicate, and then we declare validation for this in range, and we are essentially moving the code in this part. Okay, now when we want to use it, it's just for the given move, it's just to say these are 4 integers, then we check maybe that the move is valid, but everything else is checked here, and we know that it's going to be checked because we produce them in the ASP part. If we want, we can even carry more information just to report a more detailed error message. For example, in this case, I'm collecting the atom, and then maybe in the declaration of in range, I add the source. I have no idea what I will receive for this argument, so you can just say that it's any content. And then finally, everything else remains the same, maybe only in the error message, you are going to be more, to provide more detail. If you want, you can even reuse the declaration of in range, for example, for the move output predicate here. Good. How does it work? How ValAsp does it work? Essentially, we start from these YAML files. We convert them to Python code. Actually, it's Python code that is part of the core module of ValAsp. It's something like this, not very important, but just say we produce classes with some annotated, decorated stuff here and there. We use Python annotation for the fields and so on. And from this point, what we are going to do in ASP, we are going to inject constraints of this form, which means whenever the grounder is going to produce a predicate that we are interested to validate, we also invocate an add term. Add terms are then calling some Python function that we produce in this way. Essentially, we call the constructor of the class associated with that predicate. So in this case, for example, if you are going to produce sites, you are going to call the constructor of this class. In this constructor, we are going to do all the validation we are interested in. Well, what about the overhead? Because at some point there was the overhead argument. We did some check. We tried a few encoding, and as you can see from these numbers, there is no overhead. Okay, so we are talking about really no time computation. It's not even a second. If you want, you can even unplug this later. Okay, you can just use for developing and then unplug it easily because it's built aside. Nice thing, it may even work in the other direction. So it's not just Python that can help to validate ASP data, but we can also use ValAsp to introduce ASP for Python validation. So if you have a Python function, for example, and you expect as input a connected graph, if you really want to check that the graph is connected to validate this data, maybe you can map the graph to ASP relations, to ASP predicates, and then use this kind of validation from using ValAsp. And obviously there is much more inside. Okay, so now there is no time for all these details, but we have built-in support for common comparison, like if you want an ordered triple, you can check in this way instead of writing Python code. And maybe you can define custom types and validators, for example, to say that a number is even. You can check here, and if you want, you can disable validation of this predicate, because this is not really a predicate, it's just a validator. And then maybe you can use this declaration multiple times and you will get this kind of error in case you produce something wrong. Also, if you don't like flat relations, like as we have seen for the night tour, to have these 4 integers that it's unclear how they are linked, you can use functions if you want, and then you can specify validation in this way, or you can even use tuples if you prefer, and then just say that the function name is just a tuple, it's not a real function name. Well, summing up, please start to validate your data, because we want you to save your time. Don't lose time to work with invalid data. Also, this provides some kind of implicit documentation that the machine can understand, that it's usually better than just comments written in natural language. Also, validation is aside, so if you want, you can only use for the development phase of your software, and then when you go in production, just use the encoding itself, not passing via ValAsp. Okay, which means you will have exactly the same behavior that you are having now when you are in production, but in the development phase you can get the advantage of a fail-fast approach. But let me stress again, there is no overhead argument, so we are talking about less than 1 second to validate your input. And that's it. Thank you for your attention.